Hello everyone, welcome back to this Kinetic Rain Grasshopper tutorial series. In the previous video, we were left off with two models. Of course, if you wanted to make more in between, you could have done that, and then you would have to use a value list here to select the ones that you ultimately will be using. But for this tutorial, we will only have these two, so the droplet and the lamp. The lamp will probably only be used at the end to just change it up a bit. But as we continue on, what we're going to do here in this video will be to create the grid that will ultimately be where we will copy this droplets to. So we're going to go down. I'll just create here, and if I can, I will move it afterwards. So to start, what I tend to do is I'm going to make a point. So I'm just going to make point construction. First off, I want to dictate how high do I want the strings to start, like from which height do they drop from? And then from there, I can do a multiplication in the x axis and then the y-axis, and then I also have those two as sliders so that you can control how many droplets we want. So to start off, we'll do with the ceiling first, the height. I'm just going to type in, let's do 10,000 millimeters, which will be 10 meters in height. So I'll just connect that here. Right, so that will be, let's just immediately name this. So we'll call this ceiling height. Afterwards, what I tend to do is I want to create a plane. And the reason for this is, let me create an XY plane, and I'll attach here. The reason for this is, if we don't create this plane, and we are assuming that everything will just be aligned to the world XY plane, right? Then you could have just start with a point and then duplicate that point, and then we'll be fine. But let's say you want this to be diagonal, something like if I quickly draw a polygon. Actually, let me draw a rectangle. So let's say you will have something like this, and then you have the points duplicated here, right? Oops. So that's not a problem. But what if you wanted to maybe perhaps animate this so that it's sort of like do this, or you want it to be at an angle or something like that? I don't know why you would want that, but the possibility is there. So we'll just create that right now so that when we want to, we can have that as a variable that we can just, or as a parameter that we can just adjust. So because that's very easy for us to do right now, and it's best to do these things at the start. I'm going to move this because I don't want to be touching that as we build this. So we're going to build that immediate here. So what we're going to do is we're going to do a rotate. We're going to do the rotate plane, which I don't see. Oh, there we go. And what the rotate plane will take is a angle, which will be now the in radians. So we're going to right click here and then we say degrees. And then we're going to do 0, 360. We'll leave it at 0 so nothing changes. Now that we have this rotation of the plane, actually, let's drop this down here. We can't be sure that, so let's, for example, this one is now rotated. Can we see the plane? No, we can't see the plane. That's fine. Maybe we can see the plane if I plug in. Oh wait, I had it off, that's why. But in any case, so we have a plane here, and let's say this is now rotated, which means that X axis does not follow the world axis anymore. So what we're going to do, we have to make sure that our the move factor that we're going to be using is going to be always correct. So we will build from this plane, whether it's rotated or not, and then we will deconstruct that plane. From there, we can extract our axis to, well, duplicate our points. So we're going to do a deconstruct plane, like this one. It may seem very weird what I just said, but as we build this through, you will soon learn to understand why we do what we've done here. So actually, you don't really need this, but I tend to put one in between in case I want to switch this up. So if you don't want to, you can just skip this part. At least for now, I don't see the use of it, but I tend to do it here in case I need it. So with the deconstruct plane, all these X, Y, Z will be what we will ultimately use. Actually, where is my point? Oh, it's all the way up there. Okay. Well, I'll leave that on. So we'll start with duplicating to the short side. So we're gonna do a amplitude. We're gonna take the X. We are going to do a move, of course. We're gonna move the origin point, which will be that one. So we don't actually need to see this, so we can just move that point. Oops. Now, in the A, which is the amplitude, this is where we control how many points we want and how far they are from each other. So now the question becomes, how do you want to control how many points you have along this line, right? There are two ways to do that. You can either just do it like this. I'll show you this one way quickly. Let's do 20. Let's say 15 points. Oops. Oh. And then we can just do this. And then we'll do another one. We'll say, let's say this one should be higher. Let's say 500. Right. So there we go. As you can see already, if I switch to top view, this one is rotated because now it's listening to our plane rotation. So if you set it to 0, it'll be as if it's duplicating along the X world axis. So let's leave that on to 0 for simplicity, and then in the end, we'll change it to see what we can get with it. So now you can do it like this, right? You can put a stepping, control the stepping, and control the amount so that you can control how many points you want. What I prefer is I want to have a total width, right, from this point last to first, that I want to control, and then I will control how many points do I want to fit in between that. And the reason for that is if I have the total width, and let's say I want to fit this into my building, and my building has a maximum width of 7 meters, then I will know, okay, 7 meters is going to be the total width. And then I can control how many points I want in it, which is a lot better than controlling this. Now I have to do 13 times that, and that will give me the width, and then I have to play with the width in order to fit into that 7 meter, if that makes sense. So for now, I'm just going to start doing 7,000 millimeters. So I'm just going to call this width. Might even call this total width, but I think this should be okay. Oh, no, right. That's a notification from my email. Right. That notification made me lost my thought. All right. I was gonna do the count. All right, and then we'll say counts. We'll do this short side count. I think I called this differently in the original script. So we'll delete this. We'll use a evaluation command. Well, actually, we don't need to use an evaluation. I can just use the division. We'll use division. So 7,000 divided by the amount of points will give me the distance between each point if I were to have a total width of 7 meters and divide it into 12 points. With this, what we're going to do is, or actually better yet, we'll use a range. And we can put the total range here, and then we can say how many we want. That will give us also all the points in between. And that should actually quicker than doing this and then do another series here. We'll just use range, so we plug that in here. So now I control the width, right? I can control the width, and I can control how many points do I want to fit within that total width. I believe I said the original one has 15 points, so we'll leave that as 15, even though it's actually 16 elements. But that should be okay. We can play with this. All right. And now on to the other direction. Actually, can I turn off? I'm gonna turn off that one. And now we can actually move on to the other side, which we will do the same thing again. We're gonna say amplitude. We're gonna do amplitude on the Y. I'm gonna do another move, so I'm just gonna copy this one. But we're not gonna copy from the original point, but we are going to copy from here. Now, we're not, if you do a move like this, it would just move the each corresponding elements. We have to graph this output in order to make sure to tell Grasshopper every point needs to be multiplied, not multiplied, but needs to be moved according to how many we want. And I thought it was 38, so I'm just gonna say between 20 and 50, because you don't want to go too crazy. So we're gonna call this long side count. And for this part, what we have here is the in-between distances, right? So what we want to do is actually we're going to bring back the division, because what we want is whatever point is between the first and the second here, we want that also to be equal distance to the other side, right? And here we don't want to control. I mean, if you want to, you can control the total amount of length and then the amount of point you can fit in. But I prefer to have the points as equal distance. So I'm gonna use 7,000 divided by this, which will give me the distance that is between each point, and I can use that to do a multiplication. So I'm just gonna multiply that. Actually, we're not multiplying it, we're actually creating a series of points. So we want 38 points in total, and we want the step to be the distance. So when you plug this, let me actually show you what happens if you don't graph this. So let me put this. You see that the first point matches that, and then the second, actually let me switch to the top view, you can see, and then it will match that, and then this one will match this one. Because this is less, it will just continue on matching that. Now watch what happens if I graph the output of the first move command, first move component. Now what we'll do is each point will be multiplied by this whole series, and then the second point will be multiplied again, and then again and again and again. All right. Actually, this is most of the work that we can do. If you want to see how this works, you can actually copy. You can actually do a move to vector using that base point and these points, and then you can have your all the rain droplets in this grid. But we're not going to do that just now. But what we will do, let's see, is actually, let me clean this up by adding this point, and we're going to call this all points, just so we can distinguish it. All right. And now that we have the base full point set up, what we're going to do next is we're going to add the reduce in it, so that when we are making our wave, we can quickly preview how that works without having to without having to recalculate all this. How many points do we have? 608 points. I mean, it's obviously a lot faster if we were only to calculate maybe like 10% of it or something. So we're going to introduce that right now. First of all, what we're going to do is we're going to try the first method, which is to reduce at a certain pattern. So if we just look for reduce, you have the random reduce, which is going to be the second one we're going to be looking at. But we're going to look at the first reduce first, which at a fixed pattern, which we'll just use the culling actually. Yeah, we use the culling pattern. From this point, what we want to do is actually reflatten our points because we don't need that hierarchy actually anymore. So the list to flatten, the list to reduce is that. So without doing anything, let me switch to the top view. Because the cull pattern come with a false, false, true, true pattern already, you can see that we only half this to 304 points. So we want to be able to introduce our own pattern. So what we're going to do is, since 0 signifies false and 1 signifies true, what we can do is if we were to make a range, let me show you. Oops. Let me do this. And then we have something like this because default domain is 0 to 1, and then we have a default stepping. We can actually let me do 30, something like this. Now watch what happens if I introduce a rounding component, and then I say everything floor. And what floor will do, and actually let me make 2 of these panels to show you. What floor will do is you have the n, which is nearest, round to the nearest integer. Floor is always round down. Whatever is 0 comma, it will get rid of the decimals number, and then we'll round to the nearest integer. And ceiling is the other way around. So if I do floor, because the 1 is the only one that has, well, no decimal in this case, everything else will be rounded to 0. And what that will translate will be, if I just quickly put a Boolean, I hope it works like this. You'll see that it's false, 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 and then true. So we can actually use this directly, or we can use this. Grasshopper translate that automatically for you, so you don't really need this Boolean toggle. So I'm going to get rid of that. So now you can see we now have 101 points with a certain pattern. So if you increase the number of false you have, the less points you will have. So let's say for 15, we're instead of dealing with 608 points, we're only dealing with 38. So that is a lot more, a lot better, a lot less points for our Grasshopper to calculate later on. We're gonna give this a name. Actually, I don't know what to name this. Let me peek quickly to the other script. What I call this the culling pattern steps. Let me do this. All right, so that's number 1 way to reduce it. The other one is which you've already seen, which is the random reduce, which is this one. Now the random reduce, what it takes is a list. Obviously, it's going to be our points, and what it will also take is a R, number of items to remove, and just a C generator. So we're only interested in R, number of items to reduce. What we can do there is we have 608 points. We can consider this as 100%. We can convert this into percentage. So in order to do that, what we're going to do is we will have to do a list length because we want that number, that 608 number out of here. So now we have it here. And then we can time this by a percentage. So let's say 0.5, that will be 50%. And if we were to do let me do an evaluate command here. Well, actually, well, you can do it in the evaluate command. Just need to do x times y, or we can just do simple enough, just a modification in order to make the script a little bit understandable. Because I always use the evaluate because I know what I put in there. But I think for this purpose of showing you, I think it's better to do it this way, so that when you glance at it, you know exactly what it is. So I'm gonna take this reduction percentage. Reduction percentage. So that's 50%. And what we'll get here is the amount of items removed. So 50% is obviously going to be 304. We're going to plug that in here. So now we can have this, or we can have this. Um, what we now miss is actually a switch for us to decide which one suits us better. Maybe, who knows? Maybe you want to have a randomized kinetic rain instead of the full grid. So we're gonna connect this one to here, and then we're gonna make a toggle. The toggle should say, so now, wait, let me hide this. Now it is not randomized. So let's say randomize reduction, so that we know what the toggle does. So randomize reduction, which is false. So nope, no randomize. True, which is randomized. Okay, so we'll put that here. Okay. Now, if we were to increase the amount of reduction, you can see all the points start to disappear. So by reducing 90%, we have how many points? 61 points. Still not as little as this one, but still a lot better than 608 points. So now we need a different filter gate. We need another filter gate, which should ask us, use all points or not. So meaning, do we want to reduce the points or do we not want to reduce the points? So I'm just going to quickly, okay, good. I'm going to plug this in here. So false is 0. So if it were to use all point true, that will be go to 1. So meaning this should go here. So that when we are saying use all points, this use all points is this one. Use all point is true, so it goes to 1. So now, let me see, okay. Use all point true, we see all points. False, we only see whatever method we chose here, which is the random reduce. So I'm gonna put this in here. So let's say you want to randomize the reduce, or you don't randomize it, you can change here, and this just overrides the whole thing. Let me quickly do this, because OCD is killing me. All right, I think up to this point, we're set. All we need to do now is to make the outputs. So we're going to call this starting points, so that we know that we will want to start with this. We'll start with the reduce points. I'm pretty sure that we're going to be needing some of these, like the width, the amount of long side points, all this as well, but as a output for here. But we will create those as we go into the next step of our script. Oh, I forgot to do Control-Shift-V. We're going to call this the grid points. Okay, let's group that. We can place that. Well, let's place it somewhere here or here. Anyway, we'll see where we place it when we move to the next steps. All right. To quickly show you how it looks like with all these droplets on here, what you can do is do a vector from 2 points, from the attach point to the starting points. Then we can do a move from the base model to the move. I can already see that our droplet is way too small to be seen. I can't even see it. There they are. So obviously they need to be a lot bigger. So the scale, I might have to edit this to 30. Let's see, what's a good scale? Actually, I don't want to see the points, so I'm just gonna hide the points. Is this a good scale for droplets? Looks okay. All right, let's increase this further. This can just stay as one. 50? Maybe small, 40. Yeah, okay, let's say 50. But it looks kind of big. Anyway, that's up to you if you want to change it or not. Oh, we can also now test. How does the lamp? Oh, okay, the lamp looks a lot smaller too, so we need to increase that one too. Let's say 500. Oh yeah, we do need to. I haven't given this a name, but this defines the width, x, length, depth. I'm gonna do this to 50. Now let's drop this down to 300. Yeah, that looks actually maybe. Nope. Okay. Something like this looks more like small lamps. So this looks a lot better. And then we can finally say use all points. Nope. Randomize. Yes. And then we can switch back to the droplets. All right. So you can see where we're trying to go from here on out. So the next step will be to focus on the base mesh, and this will come later on. So for now, I'm just going to remove this, and then we'll do the base mesh in the next video.